So the first question from section 5.4 is, it seems like they want you to first estimate the variance and standard deviation of the sampling distribution without using the formula given on page 261. Okay, so in e-text, I'm going to go to 261. So the formula they gave us is right here. If I may zoom in. The mean of the sample means is equal to the population mean. So you just have to find the mean of these sample means. That's not difficult, but I guess without using this standard deviation formula, without using population standard deviation divided by square root of the sample size, what Nicole wants to know is, how can we find the standard error of the means? Okay, that's another name for it. I think just without this formula. So let me see what the problem was, what the example was about. I think you mentioned example number 1. Okay. So in this example number 1, I see. So right here in this section right here, after constructing a probability distribution of sample means, which means not this table, that is just everything listed. But if you take a look at right here, here is that probability distribution. So what they did was they found the mean, which obviously is 4, as you can see, is a perfectly symmetric distribution. I can see 4 is the mean, median, and mode. But her question is, it's a great question, why is the variance approximately 2.5? That's a good question. So did they explain? Let me read it, and if not, we can find it ourselves without using the formula. Without using the formula. Notice that the shape of the distribution histogram is bell-shaped and symmetric, similar to the normal curve. Mean, variance, standard deviation of the 16 sample means are. They really didn't explain. They just gave it to us, didn't they? I mean, I can see how they got 4, but it's a perfectly reasonable question to wonder, how did you get 2.5 for the variance? And it looks like what they did was they did 5 divided by 2. I would just do it. I would just do it and show you why it is 4 and 2.5. You see the probability distribution right here? How about you and I enter this and find the mean, the expected value, and standard deviation of this. What section was it from when you did expected value? That's what it is. We're finding the mean and a 5.1. 5.1 they call. But doing it by hand will probably take some time. So I'll go ahead and open this up and I'll show you how they got 4 and 2.5. Okay? All right, I'm gonna enter X bars, which is 1, 2, 3, 4, 5, 6, 7. These are the X bars. X bars. And I wonder if I can zoom in so that you can see what I'm typing. That is always going to zoom. So on the right side, on the second column, stop it. I will enter the probabilities, which goes, hold on. I do want to label this as P of X. Oh no, you know what? Probability. I'll just call it probability. And they are 1 over 16, 2 over 16, 3 over 16, 4 over 16, 3 over 16, 2 over 16, and 1 over 16. I'm worried though if I should enter decimals instead of fractions. But I'll show you how I'm about to find the mean and the standard deviation of this probability distribution. I will go to Stat, Calculators, and which one? Custom. Go to Customs. And then we're going to tell them the values are in X bar. and their weights are in, not X bar. Oh, I see. See, they're not going to take the fractions. So what we're going to need to do is convert these fractions into decimals. So what I will do is I will just close out of this calculator for a second, and I'll say probability one more time. But I'll go ahead and actually get the decimal values. So first one, I will have to do 1 divided by 16. 1 divided by 16 is 0.00625. And I think this is the same, this is the same as the one in the bottom. I'll go ahead and copy that down here. Next one is 2 divided by 16, which is 0.125. This is the same one as the one down here, 0.125. It's such a hassle to convert things into decimals, but it's not difficult. All right, that is 0.1875. But you see why, Nicole, you may want to use the formula, because in order to find the probability distributions, mean and standard deviation, we're going to have to do this. 4 divided by 16 is 0.25. So now I get my weights in decimal because I just learned StatCrunch won't take fractions as the weights. So I'll go back to stat calculators and custom. I'll tell them my values are in X bar, and I'll tell them the weights are in probability. And I will just go ahead and hit compute, and you will see it. Do you see that the mean is 4 and standard deviation is 1.58? The one standard deviation they had for us was 1.6. They rounded this up. And if you're wondering, what about the variance? If I take the standard deviation, look, 1.5811,388, and if I square it, it should be approximately 2.5. Ta-da, 2.49, repeating. So this is how you can find the standard deviation of any probability distribution using StatCrunch. But if you want to know how to find this by hand, I suggest we go back. I'm thinking maybe 230. I'll find it with you here. Not chapter 4. Not all the way. Oh, hey, you know what? I think it is chapter 4. I'll go ahead and show you the page and I'll stop. Maybe I can use this menu. We're going to chapter 4, 4.1, probability distribution. In section 4.1, on page number, it's all right. Here it is. We're getting there. Oh, so, okay, hold on. On page number, not this one more page. I apologize. I don't have these. Okay, right here, 195, they gave you a formula to find the probability distributions, variance, and standard deviation on this little orange box. And there is an example number 6 where we had to use, see, the reason I used StatCrunch's custom calculator was because I didn't want to do all these by hand, but that is how you can find, if you have the complete probability distribution, that's what you can do to find the variance of 2.5 and standard deviation of 1.6. But as you can see, that's a little too much, isn't it? Like doing all this work. So that's why I suggest you use the formula on 261. Let me show you that real quick. 261, such a good question. You're wondering, okay, there's a formula, but there's this formula right here, but how would you get the answer without using the formula? And I love what you said. You said, maybe I'm making things too difficult. Maybe you were, but hey, that's okay. You were wondering you were thinking about the why behind it, like why is that true? So I'm so glad you asked me that question. So I know that I have a couple more questions to go over, but I think that's enough for the first one. I will record a couple more explaining the other parts of your this email that I received.